Good morning, dear students. My name is Ferhan Mazher, and today is 10th April 2021. And the subject we are studying is Physics 5054. It's O levels physics. And today we have set our hearts to solve May June 2011 paper. And this we are going to solve paper 2. The number of the paper is 2-1. This paper 2 belongs from the variant 1 or zone 1. And today in this session, in this video, we are going to solve the section A of this paper. So let's start quickly this paper and let's see what it brings to us. And here we go. So the question number we have here. So this is the paper, May, June 2011 to 1, and it's a 1 hour, 45 minutes paper. This is theory paper, and this belongs from the zone 1. Today we are solving a section A. So let's start and see what happens. Okay. So the section A, question number 1, the figure 1.1 shows the speed time graph of a car. So before I go into the further question, let's first of all understand what is this. This is a speed time graph, and you can see on the y-axis the speed is represented, and on the x-axis the time is represented. The speed here is in meters per second, and the time here is in seconds. So, and one very important thing is that the speed time graph, the slope of the speed time graph, anywhere you find the slope of the speed time graph, that will be equal to the acceleration, or you can say retardation or deceleration. So acceleration, retardation, deceleration, you can find by finding the gradient or the slope of this graph. And if you want to find out the distance traveled by the body, we always find the area under the speed time graph. So these are the two facts which you should always remember when you are solving this paper. So, okay, so we will start this question. The first question is on your screen, and it says, at the time t is equals to 15 seconds, the brakes are applied and the car comes to rest with the uniform deceleration. State the speed of the car just before the brakes are applied. So here you can see at 15 seconds, the brakes are applied and then the speed started decreasing, the body started decelerating. So let's check what is the speed here. So from 10 to 15, there are 10 small squares. So 2 small squares represents 1. So it's like 11.5 centimeter. So the speed from the graph, I can tell when he applied the brakes, the car was moving at the speed of 11.5 centimeter, meter square. The question was of 1 mark, state the speed of the car just before the brakes are applied. Okay, the next question. Explain what is meant by the uniform deceleration. You see, deceleration means the decrease in the speed. So uniform deceleration means that equal decrease in the speed in equal intervals of time if the body is moving in a straight line. Or in other words, you can say equal decrease in velocity in equal intervals of time, the body is moving with the uniform deceleration. So I have written this answer. It's a 2-mark question. Let me show you my answer. And here we go. So hopefully this is showing on your screen. And let me show you. Okay. So increase the size. Okay. Here we go. So the equal decrease in velocity in equal intervals of time, that is called uniform deceleration. This is called uniform deceleration. So let's move to the next part, and the next part says, the next part is the lorry is a lorry travels at a constant speed of 18 meters per second for 15 seconds. At t equals to 15 seconds, the brakes are applied. So he's talking about another vehicle. So another lorry, and its speed is 18 meters per second, and for the first 15 seconds, and then the brakes are applied, and the lorry slows down with the same deceleration as the car. He says whatever was the deceleration for that car, whose graph we already have, this lorry also have the same deceleration. So on the figure 1.1, draw the speed time graph for the lorry. You see, when two objects will have the same deceleration or same acceleration, the slope of their speed time graph will be same. So when I will, let me show you how I did this. You see, this is that main graph. This is the deceleration of that car. And if I will draw a deceleration of the lorry, it should be a parallel line to this. So I've done this on a paper. Let me show you my work. And then this is that B first part. And let me increase the size so you can see it clearly. So question number 1B, first part. This is the black color graph, is the car graph of that car. And the lorry, it was traveling at a speed of 18 meter per second. And for the 15 second, it continued moving with the speed of 18 meter per second. So here you can see I have drawn that line with the red color. This is at a speed of 18 meter, and for 15 seconds, it continued traveling with the same speed. So it will be a horizontal line till the 15 second, and then the brakes are applied, and it started decelerating. The value of the deceleration is equal to the deceleration of the car. So this line here, it should be parallel to this black line. This red line should be parallel to this black line. So by the visual inspection, draw this line, and it should look like parallel to this. So I have tried my best to draw a parallel line to this, and it will come here at almost, I think this is 24 seconds. At 24 seconds, the lorry will stop actually. So these two lines, they are supposed to be parallel to each other because their deceleration, the deceleration of the lorry and the deceleration of the car, they were equal to each other. So hopefully you are able to understand this. And this is how much mark? This was of 2 marks. Then his question is, explain how your graph shows that while braking, the lorry travels further than the car. Okay, so let me go back to that diagram. You see, if you will find out the distance moved by the car when the brakes are, so that will be this triangle. Area under the speed time graph is equal to the distance traveled. So when you have applied the brakes, so the car, if you want to find out when you applied the brakes after 15 seconds, how much is the distance traveled, you find the area of this triangle. For lorry, when you apply the brakes, you will find the area of this big triangle. So clearly on the graph, we can see that the area under the speed time graph after 15 seconds for the lorry is greater as compared to the distance traveled by the car after 15 seconds when the brakes have been applied. The distance traveled by the car lorry is greater because the area under the speed time is greater. Another way of the brakes are applied for both the vehicles on 15 seconds. And so it means the lorry took a longer time from 15 to 24. It's like, I think it has taken 9 seconds to stop. And the car has, when the 15 second, the brake was applied, the car only took 5 seconds to stop. So clearly the lorry has traveled a larger distance. Plus another very important point is the lorry was traveling at a higher speed and it took a longer time to stop. So obviously the lorry will travel a longer distance. I have written this answer. Let me show you question number 1B, second part. The answer is showing on your screen. Area under the speed time graph for the lorry after application of brake is greater than that of the car. So from the area under the graph after 15 seconds, the lorry has a greater area under the graph as compared to the area under the graph for the car. That's why the lorry, I can surely say from the graph that the lorry will be traveling a longer distance. So that was question number 1. Let's have a look at its marking scheme also, so there is no confusion. So let's check the marking scheme, and then okay. And you know, if you are studying with me and you are following me and you pass paper practice, you know that the one advice I have for every student is that whenever I solve a paper or a question, I always check the marking scheme. It's a must. Okay, so question number 1, A part is showing on your screen, and we can say that 11.5 centimeter per second. That is the answer we also got. For the second part, decrease in the speed, that is negative gradient. Equal changes, decrease in speed in the same time, constant, negative gradient, or VT on the VT graph. So we have written the right definition. For B first part, flat line at 18 meter per second from T0 to T15, 1 mark for this, and constant slope downwards parallel to the initial line by I. Okay, so 2 marks of this one. And B second part is greater area under the graph and higher initial average speed. You can also say this. So hopefully you will be able to write good answers for this. And this is the question number 1. Let's move to the question number 2. So the question number 2 is on your screen. Figure 2.1 shows the skydiver falling vertically downward at the terminal velocity. Arrow X and Y shows two main forces acting on the skydiver. State the name of the force X and the name of the force Y. You see this X force which is acting downward. It is the weight of this skydiver, and this force Y which is acting upward, that is the air resistance, the force of the air resistance. So X is the weight of the skydiver and Y is the air resistance acting on the skydiver. Explain why the force F acts upward. You see the force Y. Explain why the force Y acts upward. This is 1 mark question. The force Y is air resistance, and air resistance is basically a resistive force. And because it's a resistive force, so it opposes your motion. So if you are falling downward, the direction of the air resistance will be opposite to your motion. It will be in the upward direction because it is opposing your motion. So, and the next question is, when the skydiver first started to fall, force X and Y were unbalanced. Describe and explain the effect of the unbalanced force on the motion of the skydiver. So when the skydiver starts falling, you see throughout this fall, the weight will be constant. The weight in that height will not change that much. So let's suppose that the weight remains constant. When he started falling, the weight was whatever the value was of the weight. Throughout the fall, the value of the weight will not change. The value of the Y at the start will be 0. So the resultant force will be, you subtract weight minus the air resistance, that will be downward direction, and that will be equal to the weight. And then the body will start accelerating downward. So gradually what will happen, the speed of the body will increase because of the acceleration in it. And as the speed will increase, the air resistance will increase. So the Y will be gradually increasing. The Y value will be gradually increasing. Okay. So he says, describe and explain the effect of the unbalanced force on the motion of the skydiver. When he started falling, there was only weight acting on downward, and the air resistance would be 0 at that moment. And he will have, and the resultant force will be downward equals to its weight. So the body will have acceleration in it. And then his speed will increase, the value of the Y will increase, and the resultant force will gradually be decreasing. But the resultant force still will be in the downward direction. The magnitude of the resultant force will be gradually decreasing, but the body will continue accelerating, but the rate of the acceleration, the value of the acceleration will be gradually decreasing. When the body is falling, the velocity is increasing, the acceleration is maximum at the starting point, but gradually the value of the acceleration decreases. Remember, it's a very good idea. Remember this idea. Then when you are falling, your velocity is increasing, it continues increasing, but the acceleration at the start is maximum, and then it gradually decreases. The value of the acceleration gradually decreases because the air resistance is increasing, and the resultant force is gradually decreasing also. So I have written these answers. Let me show you my answers, and here we come. So question number 2, you can see they are showing now on your screen. X is weight, Y is equals to air resistance. Question number 2A part. Air resistance is a resistive force. It is always opposite to the motion. Skydiver is falling downward, so air resistance will be upward, opposing its motion. Okay, so B first part is, if forces are not balanced, there will be a resultant force acting on the body. And when there is a resultant force acting on the body, according to Newton's second law of motion, the body will accelerate. So body will accelerate in the direction of the resultant force because the resultant force is downward. So the body will be accelerating in the downward direction. So let's check the marking scheme. Marking scheme says, let me check the marking scheme. And the marking scheme, what the marking scheme says. Okay, so question number 2, you can see is on your screen. X is the weight, force of gravity, gravitational force, and Y is air resistance. Okay, and wind resistance, air friction, whatever you say. Y opposes motion. Driver moves down, air molecules hit faster from the below. So the direction of the Y will be in the upward direction because it's a resistive force is opposing your motion. Acha, B, first part is accelerates, falls faster, speed, velocity greater. X is larger than Y, so the resultant force will be downward. So at the start, I told you that the weight do not change, so weight remains same. But there will be weight and the Y value will be 0 at the start. So the resultant force will be downward. That's weight minus the resistance. That will be maximum and downward. So the body will accelerate downward. So its velocity will increase. Then we have the next question. B, second part. That's on your screen right now. I can hope you can see. We can increase the size further. Yeah. He says, state what happened to the size of the force X and the size of the force Y as the skydiver falls and reach the terminal velocity. You see, during this whole fall, remember one thing, never say this. That the value of the weight change. No, the value of the weight throughout remain constant. Okay, the value of the Y, which is air resistance, that is gradually increasing because the speed of the body is increasing. When the Y value will increase, you see the resultant force is equals to weight minus air resistance. So weight is constant, and when the air resistance is gradually increasing, so the resultant force, that is X minus Y, that will, because the value of the Y is increasing, so the resultant force will be gradually decreasing. So when the resultant force will decrease, and ultimately what will happen, the Y value will become equals to the weight. When the value of the Y will become equals to the weight, the resultant force will become 0. If the resultant force will become 0, according to Newton's second law of motion, if the resultant force acting on a body is 0, the acceleration produced in the body will be 0. So the speed of the body will become constant. So actually what is happening when you are falling, the value of the Y is increasing, and ultimately what happens, the value of the Y will become equals to the X value, which is weight. And then the resultant force will be 0. When the resultant force will be 0, the acceleration will be 0, and the velocity of the body will become constant, and we call this terminal velocity. Then the body will fall with the constant velocity. Let me show you my answer. So here we go, and let me show this here. So question number 2B, second part, the answer is showing on your screen. This answer I have written. Size of force X, weight remains unchanged during the fall. Size of the force Y, air resistance gradually increasing from 0 until it becomes equal to the force X. At this moment, resultant force will become 0. When X and Y forces, they will be equals to each other. The resultant force is X minus Y. So if X and Y values are same, so the resultant force will be 0. Then the acceleration will be 0, and body will fall with the terminal velocity. Terminal velocity means that the body is falling with a constant velocity. I hope you have understood this. Let's check the marking scheme for the B part, and then we will move on. B, second part. 2 of X stays the same, Y increases, force becomes equal and opposite. So that is a 2-mark question. I hope you will be able to write this answer. So let's move to the next question, and the next question on your screen is coming. Question number 3 is talking about, okay. So figure 3.1 shows part of a small hydroelectric system that generates electricity from moving water. So you see what is happening here. here a stream of water, a jet of water is touching the blades of this turbine. So that water will make that gushing water, that running water, will with a very high pressure will strike these blades, and these blades will turn, and they through a shaft they are connected with a generator, so they will make the armature of the generator rotate, and the electricity can be produced. So this is the basic idea how the hydroelectricity is produced. So every minute water with the kinetic energy 14,000 joules emerges from the pipe. The water turns the turbine that is connected to the generator. Half of the kinetic energy of the water is given to the generator. So the water which is entering here in 1 minute, its kinetic energy is 14,000 joules, and half of this kinetic energy is given to this turbine. The water then comes out. It still has a lot of kinetic energy in it. So calculate the power input of the generator. We can find out the power input, very simple. If you know the energy and you know the time, you just divide the energy with the time and you will get the power. So I can write here the energy which is given to the generator, that is just half of the 14,000 joules. So the energy provided to the generator, that is given in the question, that half of the kinetic energy is given to the generator. So that is 7,000 joules, and the time taken is 1 minute. We don't take time in minutes, we take time in seconds in this particular formula. So power is equals to energy divided by time. So 7,000 joules divided by 60 seconds. And you will get the answer. I've done this on a paper. Let me show you my answer, and then I can show you. So here on your screen, you can see this figure, question number 3A, first part, input energy is equals to half of the 14,000 joules. That will be 7,000 joules. So input power is equals to input energy divided by time. So that is 7,000 joules divided by 60. So it will be 116.67 watt, which is approximately, when you round it off to two significant figures, it will be 120 watt. So it will be 120 watt something. So let me check the marking scheme, and the marking scheme says 120 watt. As you can see on your screen, the marking scheme says 120 watt for question number 3A, first part. So let's move to the next question, and the next question is, so that's the reason why only some of the kinetic energy of water is given to the generator. How do we know that? Because, see, the water which is coming out of the turbine, after turning the turbine, the water still has lot of speed in it. So it means that the water which entered the turbine, it has a lot of speed in it, so it has a lot of kinetic energy. But if you look at the water which is coming out of the turbine, after rotating the turbine blades, you will see that water is at very high speed. Still, it has very high speed. So it means it has not given all its kinetic energy to the generator. So let me check my answer and then we will move on. And this is question number 3, part 3, and part 3. Water coming out. The water coming out of the turbine has a lot of kinetic energy. It means it has not given all its kinetic energy to the turbine. This answer was a little difficult to, to write. So let's check the marking scheme. Water after heating the turbine still moves, has kinetic energy, velocity, energy lost due to friction and location. Some energy is used to overcome the friction in the bearings of the turbine and in the bearings of the generators. So the marking scheme is showing, so I hope that you can write this answer. So let's move to the next part. The next part is hydro. His question is, hydroelectric system uses sources of renewable energy. State what is meant by a renewable energy source. Is a 1-mark question. Renewable energy sources are those energy sources which will never run out. The renewable energy sources are those resources which replenish themselves, and you cannot exhaust them fully. If you exhaust them, they are reproduced or whatever. They are in a lot of source of that thing that will never run out. Okay. So I have written this answer. Let me show you my answer. Very simple and a famous question. What is renewable energy source? Renewable energy source is a source. You see, renewable energy source, renewable energy will never run out. A very simple 1 mark question. And then let's move to the next part. And the next part says, what's the next part? State one source of non-renewable energy. So one source of non-renewable energy like fossil fuels, they are non-renewable energy source. Like nuclear power plant, that is also a nuclear power, that is also a non-renewable. Remember this thing, because in some other questions they ask what is the nuclear power. It's non-renewable. So let's check the marking scheme. I think we have checked the marking scheme as well. Can be replaced, made, will not run out, and coal, oil, gas, peat, nuclear, uranium. Solar is a renewable energy source, remember. Okay. Question number 4 is showing on your screen. Water at a temperature of 16 degrees centigrade enters an ice making machine and emerges as ice cubes at a temperature of -5 degrees centigrade. The melting point of the ice is 0 degrees centigrade. Calculate the total energy removed from 1 kg of water as it cools from 16 degrees centigrade, changes into ice, and then cools to -5 degrees centigrade. Specific heat capacity of the liquid water is 4.2 expo 3 joules per kg per degree centigrade. Specific latent heat of fusion of water is 3.4 expo 5 joules per kg. And the specific heat capacity of the ice is 2.1 expo 3 joules per kg per degree centigrade. You see, the methodology is very simple. Here, there are 3 things happening. One, the first thing which happened was there was water at the 16 degrees centigrade and its temperature dropped to 0. So there is a change of temperature in the water. So I will find out how much heat is extracted from the water to cool it down. So that heat, because it involves a temperature change, that will be heat is equals to mc delta theta. Then the water at 0 degrees centigrade converted into ice, and there also be extract the heat. So because it involves state change, the formula for the heat here will be heat equals to m multiply L. And then the ice was formed, and then the temperature of the ice cubes dropped from 0 to -5. That is a temperature change. So the heat involved here we can find out by the formula. Heat is equals to mc delta theta. So the first heat will be for the temperature change of water from -16 to 0 degrees centigrade. I will call it heat number 1. And then there will be heat, which will be due to the change of the state from water to liquid. I will call it heat number 2. And then there is third heat, that is the drop in the temperature of the ice cube from 0 to -15, -5 degrees centigrade. I will call it heat number 3. And I will calculate them, heat 1, heat 2, heat 3, and then I will add them up, and that will give me the total heat which is taken out. And it's I think it's a 3-mark numerical. And let me show you, I have done this on a paper, and let's see. Yeah, this is showing on your screen. So question number 4, A part, that is showing on your screen, I think, and I can just read for you. Heat number 1, which involves a temperature change, that is mc delta theta. And m is 1 kg and delta c is 4.2 into 10⁻³ joules per kg per degree centigrade. And the change in temperature is from 16 to 0. So the change in temperature is 16. So I will multiply it with 67200 joules. That will be the heat number 1. Heat number 2, where the water converted into the ice cubes at 0 degrees centigrade, a state change is taking place. For that, we use the formula. Heat is equals to m multiply L, where m is the mass and L is the specific latent heat of fusion. So 1 kg is the mass, multiply 3.4 into 10⁻⁵ joules per kg. And the answer will be 34000. 4 times there is 0 joules. So it's 340,000 joules. And heat number 3, when the ice cube's temperature change from 0 degrees centigrade to -5 degrees centigrade, because it's a temperature change, so the formula for the heat will be mc delta theta. M is 1 kg and the C value is 2.1 expo 3 joules per kg per degree centigrade, and the change in temperature is from 0 to -5, so the change in the temperature is 5. So 10500 joules is the answer. So the total heat involved, I will add up H1, H2, and H3, and the final answer will be 4.2 expo 5 joules. I hope if you do it on your calculator on a hard copy of the paper, it will be very easy for you. So let's check the marking scheme, what the marking scheme says. And here we go. So the question number 1 is showing. So the final answer should be 4.2 expo 5 joules. So this was question number 4, part A. It's a numerical, 3-mark numerical, and I hope that you will be able to solve it now. Okay, so next question coming on your screen is using ideas about the molecules. Explain why energy is needed to change ice into water. Explain why energy is needed to change ice into water. You see, when you convert ice into water, you have to break the intermolecular bonds. You have to move the molecules away from each other, and you have to overcome the very strong intermolecular forces in the solid. So for this purpose, we need the energy, and the energy which we provide is called the latent heat. The energy which is provided is called the latent heat of fusion. So the latent heat of fusion needs to be it needs to be provided here. So let me check my answer. I have written this answer. So let's see what I wrote. So question number 4B, first part, energy is needed to break intermolecular. The energy is needed to break. Energy is needed to break intermolecular bonds, move molecules away from each other, and increase the potential energy of the molecules. Yes, when you convert them from ice into water, their intermolecular potential energy that will increase. So let's move and let's check the marking scheme. What the marking scheme says for this question. B, first part, the break bonds, separate molecules, give molecules more potential energy. So let's move to the next part. So that's why less energy is needed to change ice into water than to change the same mass of water into the steam. You see, try to understand this story that when you convert the water into steam, that's a state change, you have to completely break the intermolecular bonds. You have to completely overcome the intermolecular forces. And the molecules have to be moved far away from each other. And plus you have to overcome because the atmospheric pressure is also acting on the liquid surface. So the molecules which go into the gas state, they have to push the atmosphere away, atmospheric pressure also. So they have to push against the atmospheric pressure. So, but when you convert the ice into water, the intermolecular bonds are not completely broken. And the intermolecular forces don't have to be completely overcome. The molecules don't have to move far away from it. They move away from each other, but they don't have to go far away from each other. So that's why less amount of heat is required when you convert the ice into water as compared to the water into the steam. It's a 1-mark question. Let's check what I wrote, and then we will check the marking scheme. So question number 4B, second part showing on your screen. When the ice convert into water, intermolecular bonds are not completely broken. Molecules do not have to be moved far apart. Atmospheric pressure does not have to be overcome. So that's why less amount of energy is needed. Let's check the marking scheme. What the marking scheme says. The marking scheme for the B, second part, question number 4, different change in distance. Molecules not so far apart. Incomplete bond breaking. Completely bonds are not broken. Does not push atmosphere back. Does not push atmosphere back in the case of ice to liquid. Less work against the atmosphere. So that is question number 4B, second part. I hope that you have seen my answer, you have heard my description, and now you have seen the marking scheme also. I hope that you will be able to write this answer. So let's move to the next question. That's question number 5. And here we go. Question number 5 is showing on your screen. He says the fluorescent tube shown in the figure 5.1 converts the electric energy into light more efficiently than a filament lamp. So here we have a fluorescent coating. So in the gas inside the tube, both light and ultraviolet radiations are produced. There is a fluorescent coating on the inside surface of the tube. Explain the purpose of this fluorescent coating. You see this tube, if you have ever by chance broken these fluorescent tubes, you will find a white border which is coated on their walls. So that's the fluorescent coating. And what's the reason for using this fluorescent coating is that because when the UV lights, because this he said in the question that it is giving out the UV light. So when the UV light will strike the fluorescent coating starts glowing. Another reason can be because there will be also electrons traveling in this fluorescent tube. So when the electron strikes the fluorescent coating also, the fluorescent coating starts glowing. So that's why we use, and it gives us light. So that's why we use it. So let me check the my answer, which I have written here. Let me show you my answer. So here we go. When UV light or electrons collide with the fluorescent coating, it starts to glow. That is the reason why we are using it. So let's check the marking scheme. What the marking scheme says, question number 5A part, gives out visible light or glows when hit by the UV light or electrons. So very simple answer. It's a 2-mark question. Hopefully you can do this. Okay, so move to the next question. B part, he says, state the name of the one region of the electromagnetic spectrum with wavelengths shorter than the ultraviolet radiation. So let me show you my answer. Here I have written them. The code word you remember is Ronald McDonald is very ugly except Gary. Ronald McDonald is very ugly except Gary. That's the code word which we are using to remember this order. Radio waves, microwaves, infrared, visible light, ultraviolet, X-rays, and gamma rays. So as you move in this, the order which is shown here, you move towards the right side, the wavelength will decrease. His question is the component of the electromagnetic spectrum whose wavelength is shorter than the ultraviolet. So there are two components, X-rays and gamma rays. You can name anything. I have written here, gamma rays. So let's move to the next part. And the next part is question number 5, and it's C part. The ultraviolet radiation inside the tube has a wavelength of 3.6 × -7 meter. Calculate the frequency of the ultraviolet radiation. The speed of the light is 3 × 8 meter per second. So the wavelength is given, the speed is given, and they want us to find out the frequency. You remember the famous formula, the wave equation, V is equals to F lambda. V equals to F lambda. If you make F the subject of the formula, F equals to V by lambda. F equals to V by lambda. So F will be equals to the velocity of the light is given, that's 3 × 8 meter per second, and the wavelength is given 3.6 × -7 meter. You just put the values, put them in the calculator. 3 × 8 divided by 3.6 × -17 equals to, and your answer will come out to be 8.3 × 14 hertz. I've done this on a paper. Let me show you my answer, and this is showing on your screen. You can see that V is equals to F lambda, F is equals to V by lambda, F is equals to 3 × 8 divided by 3.6 × -7 equals to 8.3 × 14 hertz. So let's check the marking scheme. Okay, the question number 5, B part, you see X-rays or gamma rays, and C part 8.3 × 14 hertz. That is the right answer. So our numerical is good. and it's done. Remember this equation V is equals to F lambda, very famous, frequently tested in the exams of O-level physics. So let's move to the next question. The next question is question number 6, and here is showing on your screen. So figure 6.1 shows a bats emit short burst of ultrasound. The echoes of the ultrasound help the bat find insects and prevent the bat flying into objects. Question number A, 6A part. State what is meant by an echo. Echo are the sound waves which are reflected from a rigid body. So the sound waves which come back after reflection from a rigid body, those reflected sound waves are called echoes. So I have written this in my answer also. Let me show you question number. Okay, so question number 6 part A is showing on your screen, and let me show you. Okay, so here we have. So the sound waves reflected from a rigid surface are called echo. Okay, so this is how you will define echo. We will check its marking scheme later. Okay, so figure 6.2 shows the variation with the time of the air pressure caused by a burst of ultrasound. On the figure 6.2, draw a possible echo formed by this burst of ultrasound. So the echo which will be formed, I will draw here on this, and the echo form should have less amplitude, but their time period should be same. One precaution about drawing the echoes here is that the echoes should have the echoes, they should have lesser amplitude here, and their time period should remain the same. So I've drawn this on a paper. Let me show you my work. And okay, let me show you. And one bad thing about this is I have drawn this with the mouse, and with the mouse to draw this smoothly is a bit difficult. So but remember one thing, that the time period of this echo should be the same. So on 2 division a wave is completed. So here on 2 divisions, 2 squares, the wave is completed, but the amplitude of this echo should be smaller than the original burst of the ultrasound. So hopefully you are able to do this. Then let's move to the next part. He says state the approximate range of the frequencies of the sound audible to human. The audible frequency range for humans is from 20 hertz to 20,000 hertz. From 20 hertz to 20,000 hertz. And so here we go. This is my written answer. From 20 hertz to 20,000 hertz, or 20 hertz to 20k hertz. That's the audible frequency range for human. Okay, so let's move to the next part. And the next part is how the frequency of the ultrasound differs from the frequency of this audible range. You see, the frequency of the ultrasound is higher than the audible frequency range. So the upper limit of the the audible frequency range is 20,000 hertz. So the ultrasound frequency will be more than 20,000 hertz. The ultrasounds are inaudible to human being. I've written this answer. Let's check that answer, and then we move on. Check the marking scheme. Frequency of the ultrasound is greater than 20,000 hertz. Ultrasounds cannot be heard by human. Okay, so let's check the marking scheme for question number 6, and it's showing the marking scheme is showing on your screen. Reflection of the sound or ultrasound or waves of the same period by eye, smaller amplitude, 2 marks for this B part. And C part, first part is 20 to 20,000 hertz and higher than. The frequency of the ultrasound is higher than the 20,000 hertz. So that was question number 6. Let's move to the next part. And the next part is coming on your screen. And now you can see this. The figure 7.1 shows the structure of a circuit breaker that uses an electromagnet. The circuit breaker operates when the current is 10 ampere. So here you see we have this, this is electromagnet, coil around it, and the current is passing through here to this contacts, the current is going out. Here we have attached a spring which is trying to pull this copper bar to the right. Here we have the iron bar which is acting like a lock for this copper bar. It is stopping this copper bar from moving to the right side. If somehow this iron bar goes up, this lock will be opened and the copper bar will move to the right side, and this contact will be broken and the supply of the current will be also cut off. So let's go to the question. What is the question? And he says, on the figure 7.1, mark with an arrow the force on the iron bar caused by the electromagnet. So you see when the current will flow through this coil, this will become an electromagnet. This is iron bar, which is made of iron, which is which is a magnetic material. So it will be, a force will be acting on this iron bar, which will be acting in the upward direction. I have shown this. Let me show you my diagram. So here you can see that I have drawn this. I have marked here the force which will be experienced by the iron bar due to the electromagnet, and that force will be in the upward direction. So force on the iron bar, you can see clearly I have shown there with an arrow. So let's move to the next part. He says, suggest one reason why the iron bar does not move when the current is less than 10 ampere. You see what is happening here. When the current is less than 10 ampere, this electromagnet will be electromagnet, but it will be not strong enough to lift this iron bar upward, because the force which with which this electromagnet will be attracting the iron bar, that will be less than the weight of this iron bar. So the iron bar will not move up. I've written this answer. Let me show you my written answer also. So here we go. So it says when the current is less than 10 ampere, electromagnet is not strong enough to lift the iron bar upward, because the force which provided the force of attraction between that electromagnet and the iron bar is less than the weight of the iron bar. So that's why the iron bar will not move upward. Okay. So hopefully you have understood this part, and let's move to the next part. And you see, the next part is, he says when the current is greater than 10 ampere, the circuit breaker stops the current. Explain what happens to the circuit breaker when this occurs. Let me explain you. When the current is more than 10 ampere, the electromagnet which is formed here will be very strong. Its attraction between this iron bar will be strong enough to lift its weight. So the force of attraction between that electromagnet and this iron bar will be more than the weight of the iron bar. So this iron bar will move upward. When this iron bar will move upward, you see this lock system here. This copper bar will be no more locked. So due to this spring, this copper bar will move towards right. When this copper bar will move towards right, this contact here, that will be broken. And when this contact is broken, the current going out, its path will be broken, its path will be opened, and no more current will be flowing out of this beaker. So the current supply to the appliances will be cut off. I hope you have understood this. Let me show you. I have also written this answer. So let's see. This is on your screen. The answer is showing question number 7C part. When current is greater than 10 ampere, electromagnet will be strong enough to lift the iron bar upward. copper bar will move to, when this iron bar has gone upward, the copper bar will move towards right due to the spring attached with it. Contacts will be separated and from each other. So the current out will become zero. So the flow of the current out of the breaker will be cut off. So hopefully you will be able to write this answer, and let's see what is the D part, and then we will check the marking scheme. Okay. State and explain how the electromagnet can be altered so that the circuit breaker stops the current at less than 10 ampere. So how you can alter the electromagnet, how you can state and explain how the electromagnet can be altered. So what should I do it? So at a less current, the breaker should stop and the breaker should trip. So put more number of turns of this coil. When you put more number of turns of this coil, you see this will become a stronger electromagnet even at a smaller amount of current, and it will be able to lift the iron bar, and the breaker has tripped. So use more turns of coil in electromagnet. Use more number of turns of coil in the electromagnet. It will become strong at smaller amount of current to lift the iron bar. I hope you have understood. And let's check the marking scheme for question number 7. And because during this question we have not checked the marking scheme. Okay, so here we go. Upward arrow not curved on iron bar, B first part. Attraction force not enough, weight of the bar too high, friction at the pivot with the copper bar, 1 mark for this thing. And the C part was electromagnet works, magnetic field created, iron bar moves lifted up, spring pulls copper bar, cross contracts and contacts break, and break circuit, contacts open. This was a 3-mark question. I hope that we have written a good answer and you are also able to write a good answer. D part is more turns in the coil, more iron in the electromagnet. Electromagnet nearer iron bar less weight, weaker spring. Correct explanation which involves force on the iron bar. So if you will use more number of turns of the coil, so at less amount of current, the electromagnet will be strong enough to lift the weight of the iron bar. So let's move to the next question. The next question is question number 10, and let's see what are the questions. Sorry, question number 8. I said question number 10. Okay, so this is the question number 8 coming on your screen. Question number 8 is showing on the screen. A wire carrying a current in a magnetic field experiences the force due to the current. On the figure 8.1, insert the words current, field, and force in the boxes to show the relative direction of the current, the magnetic field, and the force. So this is Fleming's left-hand rule. If you stretch your fingers of your left hand in such a way that they are perpendicular to each other, these 3 fingers. This is the thumb, and this is the index finger, and this is the middle finger. So they are perpendicular to each other. You can see they are mutually perpendicular to each other. We stretch it like this. This thumb represents the force experienced by the conductor, and this index finger represents the magnetic field, and this represents the direction of the current, and that current is, remember that thing, very important, conventional current. So FMC, force, magnetic field, and electric field or direction of the current. So I've done this on a paper for you, so you can see that. So the thumb will be representing the force, the index finger will be representing the magnetic field, and the middle finger will be representing the conventional current. So hopefully you are able to do this, and let's check the marking scheme also. So okay, so question number 8, all 3 correct: force, field, and current. Field means magnetic field. Okay, so let's go to the next part, and the next part is this. This B part. Let's put it here. So what the B part says, figure 8.2 shows a current carrying coil A, B, C, D in a magnetic field. Each side of the coil is 4 centimeter in length. The force on the AB is 20 Newton and the force on the CD is also 20 Newton. So calculate the total moment produced caused by these forces. You can see here is the axis of this coil. So around this axis, this coil will be rotating. This force is of 20 Newton. The total side BC is, or AB side is 4 centimeter. So from axle to this force, the perpendicular distance will be just 2 centimeter. And this force on the AB side is trying to produce a clockwise moment. The force on the DC side is also trying to produce the clockwise moment. So when I will find the moment by that force and moment by this force, and I will add them up. So when I will add them, the total moment I can produce, the force here is 20 Newton and the moment arm is just 2 centimeter. And you know the moment is equal to force multiplied the distance. And that distance means the perpendicular distance between the force and the pivot or the axis. So let me show you my answer. I've written this answer. I've done this numerical here, so you can see that. So question number 8B, first part, you can see the moment will be equal to F1 D1 plus F2 D2. Both of them are producing the clockwise moment. So 20 Newton multiply 2 centimeter, 20 Newton multiply 2 centimeter, add them up 80 Newton centimeter. If you want to write the answer in the Newton meter, which is normally the unit of the moment, so convert, divide it with 100 and it will be 0.8 Newton meter. 0.8 Newton meter. Let's check the marking scheme. What the marking scheme says, the marking scheme says 0.8 Newton meter is the right answer. The 0.8 Newton meter is the right answer. So for the next question, let's have a look at the marking scheme here. So to more turns, soft iron, and more current, increase ABCD, AB or CD length, and increase BC and CD. Okay. So let's check what is the question and then we will see what is our answer. So we are done with that 2-mark numerical and now we are going to this question. It says the moment is increased by using a stronger magnetic field. Yeah, you can increase the moment in the motor by using a stronger magnetic field. State 2 other ways to increase the moment. The 2 other ways, you see, the number of turns in that coil that should be increased, and another way can be put an iron core in that coil, and around that iron core you will bind the coil, and that will make it the turning effect will increase. Another way is introduce more current into the coil. If you put more current into the coil, it will be turning at a the turning effect will increase. So let's check the marking scheme again. I have written this answer. First check that one. So here we go. Use more turns of the coil, or you can say use a soft iron core in the coil. So that will make the turning effect stronger. Let's check. Let's have a look at the marking scheme once last time for this answer, so we have no confusion. More turns on the coil. Use soft iron. More current. Increase AB or CD. So that is question number 8 and this part. So, my dear students, by doing this question, we have reached the end of this section A of this paper. And today in this session, we have done A section of this paper. Today we have attempted May, June 2011, Physics 50521. And section A of this paper belongs from the zone 1. I hope that this video is useful for my students who are watching me on the YouTube at their homes, and their physics concepts have improved. I'm trying to improve the quality of these videos and the way in which we explain the concepts. But my energy is coming from my students. You see, when you see this video and you find this video helpful to you in preparing your Cambridge exams, kindly subscribe to my YouTube channel. Also, press the like buttons. And if you have any comment, kindly don't hesitate to comment. And recommend these videos to your friends also, and ask them to see and improve in physics. So I think that that's enough for today. Today we have only solved the section A of this paper. The section B of this paper is already in my YouTube channel. You can find it, the section B of this paper, in my YouTube channel. So I think it's enough for today. So thank you very much, everybody. Have a good day, and God bless you all.